let's write the explicit and recursive equations for geometric sequences. So the explicit is going to be in the form of T of n equals the 0th term times the multiplier or common ratio raised to the power of n. Okay, so if this is our first term, our 0th term would have to come before it. So maybe I need to know my multiplier or my common ratio first. So let's follow the pattern. 1/4, 1/2, 1, 2, 4. Looks like my multiplier is 2 because it's doubling each time. Okay, and my 0th term would have to be before this. So I would have to divide 1/4 by 2, which would be 1/8. And that is the explicit formula. Let's check our equation. Let's find T of 5. Okay, or yeah, T of 5. All right, so we'll plug in 5. The answer should equal 4. All right, 2 to the power of 5 is 2 times 2 times 2 times 2 times 2, which is 32. So T of 5 equals 1/8 times 32. Okay, I'm going to put 32 over 1. I can cross simplify, and I get T of 5 equals 4. So that equation works. All right, so this is the explicit. And I was just checking my work here to make sure it works. The recursive would be in the form T of n plus 1 equals T of n times the multiplier. Okay, and then you have to give a little piece of info. So in this case, our recursive equation would be T of n plus 1 equals T of n times, and our multiplier is 2. And then I have to give a piece of information. I know 5 terms. It doesn't have to be the first term. So let's say I gave T of 2, the second term, equals 1/2. So that would be the recursive, this piece. I'd like you to pause the video and try this one on your own. If you are unsure, go back and watch the beginning and get the formulas, and then you can substitute in as you go. So let's solve this. The explicit, I need the 0th, and I need the multiplier. So the multiplier looks like 3, and our 0th would have to be the term before 3, and that would be 1. So the equation is T of n equals 1 times 3 to the power of n, which can more simply be written as 3 to the power of n. All right, so again, the multiplier is times 3. And to go back to the 0th term, you'd have to divide by 3. So 3 divided by 3 gives you 1. Okay, let's try the recursive. We always start with T of n plus 1 equals T of n times the multiplier. So in this case, that would be 3. And then you have to give a piece of information. Yours may look different than mine. I'm going to give maybe the third term. And that equals 27. You could have given me T of 1, which is equal to 3. And that would still be a correct answer. You just have to give a little piece of info about the sequence. All right, I'm going to do not that one first. So on these problems, I'm giving you an explicit formula, and I want you to find the first 5 terms in the sequence. So whenever someone asks for that, I like to write out 5 terms, so I know I have to find that many. Those are just blank spots. Okay, well, if I want to find t of 1, the first term, I got to plug in 1. T of 1 equals 4 times 2 to the power of 1. 2 to the power of 1 is 2. 2 times 4 is 8. Let's find the second term in the sequence. T to the power of 2 equals 4 times 2 to the power of 2. 2 to the power of 2 is 4. 4 times 4 is 16. Find the third term. Plug in 3 for n. 2 to the power of 3 is 8. 8 times 4 is 32. T to the power of 4. Same process. 2 to the power of 4 is 16. 16 times 4 is 64. I'm pretty sure I know this one. Let me just double check. Yes, all right. Okay, 2 to the power of 5 is, I don't have that memorized, I'm at 32, and then 32 times 4 is 128. And those would be the first term. So you can see that the 0th term, okay, the multiplier is what? And we see it in the equation. This is the multiplier. And we'll see it in the sequence here. Everything is doubling. Okay, and our 0th term, we'd have to go backwards, so we'd have to divide by 2 and we get 4. So the equation matches the sequence perfectly. Oops. All right, I would like you to try this one on your own. Pause the video and try to write out the first 5 terms. All right, let's start. Let's find the first term. T of 1 equals 2 to the power of 3 to the power of 2 times 3 to the power of 1, which is equal to 6. T of 2 equals 2 times 3 to the power of 2, which equals 18. T of 3 equals 2 times 3 to the power of 3. Whoops, almost rule 4. 3 times 3, or 3 to the power of 3 is 27 times 2 is 54. And we'll repeat the process until we're done. All right, 3 to the power of 4 is 81 times 2 is 162, and we have one last term. Three to the power of 5 is 243 times 2 is 486. All right, and you'll see the pattern. It's tripling each time. So let's double check that. 6 times 3, 18. We've got 18 times 3, 54. 54 times 3, 162. 162 times 3, 486. And if we divide it by 3, we get our first term, our 0th term of 2. All right. Let's say I gave you a recursive equation and I wanted to know, let's go with the first 4 terms. And this one reads t of n plus 1 equals t of n times 1/2. And t of 1 equals 8. So we already know a piece of the puzzle. We know that the first term is equal to 8. To find the second term, we're going to take we're going to take the first term and multiply it by 1/2. Okay, because 1 plus 1 is 2. Now I can substitute in that 8 because I know t of 1 equals 8. I'll multiply it by 1/2, and now t of 2 equals 4. And I can follow that process to find t of 3. So t of 3 equals t of 2 times 1/2. So t of 2 was 4 times 1/2. So now we know t of 3 equals 2. And I know the pattern now. I know the multiplier is 1/2, so I can continue the process. And this next one would be 1. Please try this one on your own. I want to know the first 4 terms. Pause the video. All right, here we go. It told us a piece of the information. It told us that t of 1 is 4. All right, and now we want to find t of 2, so we'll use this. So n, for the only way to make the inside of the parentheses equal to 2 is n has to be 1. So t of 1 plus 1 equals t of 1, because the n's need to match, times 3. So now we know t of 2 will equal whatever t of 1 is, which is 4, and then times 3. So that'd be 12. All right, and then we'll continue the process. If we want it inside the parentheses to equal 3, n has to be 2. So t of 2 plus 1 equals t of 2 times 3. So t of 3, I just added them, equals the second term, which is 12 times 3. And now t of 3 equals 36. All right, and then I continue the pattern. I know the multiplier. It's right here. So it's multiplying by 3. So 36 times 3 is 100. And those are your first 4 numbers in your geometric sequence. If you're still stuck, I recommend rewatching this video.